Hi, I'm Keon, and today in this video, I'm going to show you two interesting integrals to solve that are pretty can be interesting, and they can sometimes trick us. So, the first one, we have the integral of 1 over x squared minus x plus 1. The first thing you might notice is that this integral probably uses partial fraction decomposition, but the thing is that we cannot use this method because the denominator is not factorable, and also it has no real solutions, this equation. And because we're in the context of integrating real numbers and real variables, not using sometimes like gamma functions that can be extended to using the imaginary numbers and variables, we're just sticking to the real variables. So we cannot use partial fraction decomposition, use substitution, trig substitution. But one thing that we can do is maybe we can try to factor this out by completing the square. So what I mean is that we can write this integral as the integral of 1 over, and then let's write this as x and then minus 1 over 2, and then whole thing squared. And if we square this, would be 1 over 4, but we need to get to 1, so we need to add 3 over 4 to it. And if you simplify it, you get the same thing, because x squared and then minus x we have, and then 1/4 plus 3 over 4 is 1. So this is a pretty familiar integral. This reminds me of the arctangent form of 1 over u squared plus a squared. But here we know what is u is x minus 1 over 2, but what is a? A is the square root of this, so it's square root of 3 over 2. And then now, what we need to do is that we should need a u sub. So if I let u to be equal to x minus 1 over 2, and then by differentiating both sides, I get that du is equal to dx, because the derivative would be 1, so they're equal. And now I can put this integral to a new variable. So I can write this as the integral, and then 1 over, I have u squared, and then I'm gonna write this 3 over 4 as root 3 over 2 and then squared, because we need it to be in form of arctangent of 1 over u squared plus a squared, and then we have du here. Okay, so now we are ready to integrate it. This is a very easy integral. So this is just 1 over a is root 3 over 2, so it's 2 over and then root 3, and then we don't need to rationalize the denominator, it's okay. And then we have arctan, or I'm writing as tan inverse, tangent, and then inverse. And then we have the u, which is in this case x minus 1 over 2 divided by a. So this would be 2 times x minus 1 over 2, and then divided by 3, divided by root 3. And then a plus c at the end, which will be the answer to this question. Okay, we can move on to the second integral. So we have the integral of x squared over 1 plus x to the power of 6. So in this case, what I'm going to do is that I'm going to write this integral in a different form. I'm going to write it as x squared, and then over, and then I have 1 plus x to the power of 6, but I'm going to write this as 1 plus x cubed and then squared, because using the powers, the rule of powers, these are equal. Now what I'm going to do is that I'm going to do a and dx at the end. Now what I'm going to do is that I'm going to do a substitution. I'm going to let sorry, I'm going to do a substitution. I'm going to let u to be equal to x cubed, and then differentiating both sides, I get that du is equal to 3x squared dx. 3x squared dx. Now, if I want turn this integral to a new variable, I can write it as the integral, and then x squared, if we divide, because we should divide 3x squared to both sides to get dx alone, we see that x squared cancel. Actually, a 1/3 is sticked out of the integral, 1/3, and then we have 1 over, multiplied by 1 over, and then we have 1 plus u squared. Okay, 1/3 is a constant, so it can be taken out, but 1 plus u squared, again, is a pretty familiar integral, is the arctangent of u, because in this case, a is just 1, because square root of 1 is 1. And then, so the final answer to this question is 1 over 3, and then we have tangent inverse of u, but we made a substitution that let us know that u is the same as x cubed. So we can write it as x cubed and then a plus c at the end. Thanks for watching. Thanks for listening.